So what we have here is a visual of our 5 reactions that we talked about yesterday. So number 1, we have Ned. Is it Ned? And is it Maud? What's her name? Maud? Ned and his woman. And we have Homer and Marge. So what type of reaction do they undergo? Yes. Double replacement. Do you say why?
No, I know that.
You know that? Everybody. So, for those who were not here yesterday, they just switched partners. So, Ned is now with Marge, and Homie is with whatever, Homer.
Homie.
But still, this is what she calls him, Homie.
That's cute.
Okay, number 2. Here we have Bart, and he loves Jessica. And then we have something that happen, and now they kind of look like they hate each other. So, what kind of reaction is going on here? Decomposition. They broke up. Number 3, combustion. So a combustion reaction will result in light and heat. What about number 4? What's going on in 4? Synthesis. And number 5, single replacement. Here, Marge gets replaced by a donut. Yeah, I downloaded it from somewhere. So there you go. There is a visual at what we looked at yesterday. So today, we're going to go into combustion.
Oh, yeah. I took notes on that last night, because I thought I fell asleep in your class, and so I thought you were number 5 while I was asleep. I was like, oh, man, I missed it, so I took it.
Look, you're ahead of the game. Combustion. All right, combustion occurs when something combines with oxygen. When it combines with oxygen, we get heat and light. Okay?
Was one of those on the homework?
Mm-hmm.
Okay.
8 and 11?
Yeah.
Okay.
Oh, shoot.
So what happens is the following is you have a compound. It's either a carbon-containing compound or a hydrogen-containing compound. So it has to have carbon in it or hydrogen or both. It has to react with oxygen. And when it reacts with oxygen, if carbon is present, then we get carbon dioxide as one of the products. If hydrogen is present, then one of our products is water. If both of them are present, then we get carbon dioxide and water. So you have to have something, a carbon or hydrogen reacting with oxygen to produce carbon dioxide and or water. So here you see, yes?
Okay, I have a question though, if combustion is supposed to be like heat or heat and light, how is water doing here?
So if you take water if you take hydrogen. Well, that's kind of a good question. I don't know.
Science is dumb.
Yeah.
This wouldn't be alive.
So
You're just not going to answer.
if you have, so here we have a hydrocarbon. It contains carbon and hydrogen in my reactant, and then it reacts with oxygen and it produces carbon dioxide and water. If we had carbon and we react it with oxygen, we can get carbon dioxide. If you have hydrogen and you react it with oxygen, then you can get water. Okay, those are all forms that we can get.
How do you know? So it's not synthesis.
So it can be, so combustion can be synthesis.
So it's like
It can be both. Okay? You don't have to be just one type of reaction. You can be both.
Wait.
So here we go. Let's do another problem. All right. So it makes water and or carbon dioxide. You choose it on what elements exist. So here we have carbon and oxygen, and it gives me carbon dioxide. Here I have C2H5OH. So I have carbons and hydrogens and an oxygen in here reacting with oxygen, and it's going to produce what? Combustion. And what is combustion produce? CO2 and H2O. There's a C present. So CO2 has to be made. There's a hydrogen present. So water has to be made. And then you go back and you have to balance it. These are those ones that are always a little doozy to balance. So we put a 2 here.
It's a doozy. Miss, what is that word you said yesterday?
We have a 5 here. Oh, which means this needs to be a 2. 4. Eight. And, oh, there's 6. Sorry.
We got it.
6 hydrogen, so I need a 3 there. So 6, 7, 8. 3, 5. Oh my gosh, I can't even count.
Goodness.
No, that has. Oh my goodness, what is wrong with me?
It's okay. I think we understand the point.
We know how to do it, it's just a lot of math.
It is a lot of math. All right, we're just going to ignore the. If we put a 2 there, I'll obsess over this. If I put 2 there, now we need a 3 there. So we have how many oxygens? We have 3. And 5 is 7. So if I put a 3 there, that gives me 7 oxygens. So 1, 3, 2, 3.
No. Go.
What?
I don't know. I think I'm hearing things.
You really are.
Okay.
Woohoo, we got it.
Hydrogen and oxygen, they combine, and what's the product we get? H2O. Do we get carbon dioxide? Why not? There's no carbon present, so then we need to balance this, and there we go. Mm-hmm. Okay, so this is the thing that will get you on the day of the test or the day of the quiz, is I will say propane C3H8 combusts. I will say write the formula equation and balance it. And you'll sit there and you will, I don't have enough information. I don't know what I'm doing. Propane combusts, what's that mean? I don't know. But combusts tells us a lot. We know that we have C3H8, and it combusts, which means what? It reacts with,
Oxygen.
and it produces what 2 things? And water. And then you go back and you balance it with a 3 there, and a 4 there, and a 5 there.
Oh, yeah. Wow.
Okay. That's just like we did yesterday. If I say that lead reacts with oxygen, I expect you to be able to write the whole reaction. Lead reacts with oxygen. And now I can figure out what they are going to produce. Lead is a +2. Well, it doesn't tell me, but it might say lead 2 like that, so you know it's lead 2. So it would be PbO. And then you go back and balance it. 2, 2. When you see something like here where it says lead 2, or it just says lead, and you're like, I don't know the charge of lead. You don't need to know the charge of lead right here to write lead's formula. It's a free element, so it goes as itself. Okay, so what we're going to do next is take a look at our worksheet.
It's in this packet, right?
No, I'm fixing to hand it out. Okay, so here are your steps. Step 1, change the word equation to formula equations.
Okay.
Keyword says watch your charges and your polyatomics. The other thing I want you to watch is to look out for, that is so weird, look out for covalent bonds.
Oh, no.
Because if you miss that covalent bond, you're going to be putting some formulas or some charges in there. All right, so let's go ahead and take our word equation. And what I'm going to do is I like to just start out by putting my charges at the top if it is an ionic compound. So iron 3, what's the charge of iron? Oxygen, what's the charge of oxygen? -2. Reacts with hydrochloric acid, what's the formula, or what's the charge on hydrogen? +1. What's the charge on chlorine? -1. Produces iron 3. So we just established it's a 3, and chlorine is a -1. And then water. Water is a covalent compound, so I don't care about the charges, and we should know its formula by now. All right, so what is the formula for iron 3 oxide? Fe2O3. Hydrochloric acid, what's the formula for that? HCl.
You need help?
Iron 3 chloride, how many? FeCl3. For every 3, or for every 1 chlorine, we need, or for every 1 iron, we need 3 chlorines. Of course, I am recording, and I would be like full of nonsense today. And water. The next step says, include the abbreviations for states of matter. So that means I need my solid, liquid, gas, or aqueous. But in here it doesn't tell me anything, so right now that we don't need to do number 2. Number 3, balance the chemical equation. So now we need to balance it.
Wait, so we're not doing the reaction types?
Here we are. We're only on step 3.
Oh, I get it.
So if we balance this, I need to have 2 irons. I need to have 3 oxygens over here. And I need to have 6 HCl's. And then lastly, step 4 says classify the types of chemical reactions. So we're only classifying into one type right now. So what kind of reaction is this? Double replacement.
DR.
Are there any questions on that? So that's what you're going to do for the rest of the class period is you're going to work on those. When you're done, you turn it in. If you don't finish before the end of class, then it's homework. And then I will be able to come around and help people. If you know what you're doing and you want to go around and tutor people, then that's fine too. Okay? All right, let's get started.